Hi, I'm Dima Chizhevsky, Chief Architect of GEO protocol. In our previous video, we briefly introduced the basic concept of Trustlines. Now, we're going to dive back into the subject for more details. But first things first. In this video, we will discuss GEO protocol's Trustline database structure. And the video that will follow this one will deal with the GEO Trustline mechanics. So, let's get started. As we've already discussed, all the information about a node's connections and operations, as well as its current state, is only stored on that very node itself, locally in an SQLite relational database. Technically, there is no separate Trustline database, but a portion of the complete node's relational database is dedicated to Trustlines and operations with them. So, here we will describe the part of the node's database relevant to the storage of Trustline information. This is how the overall structure looks schematically. Please note that this is currently under active development, so some details are subject to change. For the most current version, you can always refer to the documentation on GEO protocol GitHub. All links are in the description. We'll outline here the current status, which is more than sufficient to dive deeper into the Trustline logic. So, as you can see, we have several tables here. Let's have a closer look at each of these tables and the fields they contain. The first table is the Trustlines table, and it consists of the following fields: ID, contractor ID, state, and equivalent. ID field contains a unique positive integer that consists of 4 bytes. It is used to identify the Trustline by the node. Every node uses its own identification order for its Trustline that doesn't synchronize with other nodes. That means that the same Trustline between two nodes could, and most likely will, have different ID numbers on each side of the Trustline. In other words, in each of the nodes' databases. Trustline ID is used to link all the Trustline data that could be stored in different tables of relational database. Contractor ID field contains a unique positive integer that consists of 4 bytes. It is used to identify a node with which the current node has opened a Trustline. We call such a node a contractor. This field is used to link the Trustlines table to the Contractors table. State field contains a positive integer that consists of 1 byte. It defines the state of the Trustline and can have one of the following values: init, active, audit pending, archived, conflict resolving. The meaning of the states will be described in the next video. Equivalent field contains a positive integer that consists of 4 bytes. It defines an equivalent in which the Trustline is opened. The next one is the Contractors table that consists of the following fields: ID, ID on contractor side, and crypto key. ID field here is the same identifier that is located in the Contractor ID field of the Trustlines table and is used to relate a Trustline to a particular contractor. ID on contractor side field contains a unique positive integer that consists of 4 bytes. It is used to identify the current node by the contractor node, since, as was mentioned above, every node has its own identification order of its contractors. Crypto key field contains cryptographic data that is used to encrypt and decrypt all types of Trustlines-related communication messages, as well as for some payment-related messages between the two nodes. Next, we come to the addresses table, consisting of the following fields: contractor ID, address type, address. As a node can have several addresses of different types, all of that information is stored in this table and is linked to a particular node by its contractor ID. Key tables. Every Trustline operation requires that both participants agree on it. This agreement is reached by signing with Lamport signatures of both sides, so there are 2 tables for storing them: own keys and contractor keys. These tables have similar field structures, but the own keys table has one additional field: private key. And here are the fields that these 2 tables have in common: hash, Trustline ID, public key, number, is valid. Hash field contains a 32-byte hash value of the public key in the same table. It is used to link the public key with other entities in the database. Trustline ID field contains the Trustline identifier that is located in the ID field of the Trustlines table and is used to relate a key to a particular Trustline. Public key field contains a 16 kilobyte Lampert public key, own or contractors, depending in which table this field is. Number field contains a sequence number of a key in the node's key pool and consists of 4 bytes. IsValid field contains a byte field with a value of either 1 or 0, which indicates whether the key was already used or not. Private key field is present only in the own keys table. It contains a 16 kilobyte private key of the Lampert key pair. This table stores the current state of every Trustline, which we call the audits, signed by both parties. The audit is conducted after every change to the Trustline, such as opening, setting or closing a Trustline, as well as when triggered by an audit rule. For more information on this, please refer to our next video. So, the Audits table contains the following fields: number, Trustline ID, own key hash, own signature, contractor key hash, contractor signature, balance, incoming trust amount, and outgoing trust amount. Number field contains a positive integer that consists of 4 bytes and defines the sequence number of audit. The sequence number is needed to prevent various possible manipulations with audit's order. Trustline ID field contains the same identifier of a Trustline as that found in the ID field of the Trustlines table and is used to relate an audit to a particular Trustline. Own key hash field contains a 32-byte hash of the public key with which the node has signed the current audit. It is the same value that the field hash from the own keys table contains, and it is used to relate this key to a particular audit. Own signature field contains 8 kilobyte signature of the current audit performed by the node. Contractor key hash field contains a 32-byte hash of the public key with which the contractor has signed the current audit. It is the same value that the field hash from the contractor keys table contains, and it is used to relate this key to a particular audit. Contractor signature field contains 8 kilobyte signature of the current audit performed by the contractor. The fields balance, incoming trust amount, and outgoing trust amount contains the values of current balance, incoming and outgoing trust amounts. We described these Trustline properties in our previous video. Here, we will just mention that CB is a 33-byte integer and ITA and OTA are 32-byte integers. Payments receipts table. In a course of payment transactions, a node can receive or send a particular amount from or to its neighbors. These amounts are stored in 2 tables: incoming payment receipts and outgoing payment receipts. These tables have similar field structure, except that the incoming payment receipts table has one additional field, the signature. And here are the fields that these 2 tables have in common: Trustline ID, audit number, transaction UUID, key hash, amount. Trustline ID field contains the same identifier of a Trustline as that which is located in the ID field of the Trustlines table and is used to relate a receipt to a particular Trustline. Audit number field contains the same identifier of an audit as that which is used in the number field of the audit table. This field defines that the current receipt belongs to a particular audit. Transaction UID field contains 16 bytes of a universal unique identifier of a payment transaction that this receipt belongs to. Key hash field contains a 32-byte hash of a public key, the contractors, if this field is in the incoming payment receipts table, or the node's own, if this field is in the outgoing payment receipts table. Amount field contains a 32-byte integer that quantifies a sum that was transferred. Signature is the field that is present only in incoming payment receipts table and contains 8 KB signature of the current incoming receipt. Registry of Equivalence. The Futures table isn't solely a part of a Trustline database structure, since it is also used for other things. But a part of this table definitely is. And that's the following field in particular: Equivalence Register Address. The Equivalence Register Address field contains an address of the registry of equivalence that the node uses, currently Ethereum contract address. This network-wide registry contains the list of all equivalents, like BTC, USD, etc., that are used in the GEO network, as well as their identifiers. All trust lines and transactions of all nodes in the network should use the same registry, so the node can be sure that given identifiers correspond to their appropriate equivalence. However, it is technically possible that a particular node, or a group of nodes, can use a different registry of equivalence, their own for instance. But GEO protocol forbids opening a trust line between two nodes if these two nodes have different registry of equivalence. Moreover, if a node opens a trust line with another using a particular registry address, all other trust lines of this node must be opened using the same address. It is done to avoid confusion. When one node thinks that it sends, for example, Bitcoin, and another node thinks it gets, let's say, Ether on the very same trust line. The check necessary to ensure this rule is respected during the trust line opening procedure will be described in our next video. So, that was the overview of the GEO protocol's Trustline-related database scheme. In the next video, we will explore the GEO Trustline mechanics, or how Trustlines operate in GEO protocol.